In section 4.5, we're going to look at graphs of sine and cosine functions. So what you'll learn about is how to sketch the graphs of just your basic sine and your cosine. We'll look at amplitude and period to help sketch graphs, and then we're going to sketch translations. So those are shifts to the left and right, up and down, and stretching, which is really more of an amplitude. So that first bullet here, you'll study techniques for sketching graphs. If you look at this graph right here, I need to turn my pencil on here for a minute. If we look at this graph right here, we'll go blue. This is your sine graph. And so again, this is all, it's like taking your unit circle values as you go around and around and around and putting it onto an axis to graph it. So if you look at your sine graph, and remember your sine are your y values on your unit circle, your sine graph has this point right here at 0, 0, right? And if you look at your unit circle, when your angle measure is 0, your sine value is 0. And then when your angle measure is pi over 2, your sine value is 1. And so that's why we have that point up there at 1. And then when your angle measure is pi, your sine value is 0. When your angle measure is 3 pi over 2, your sine value is -1. And when your angle measure is 2 pi, your sine is 0. And then what happens is these are like all the quadrants, right? So this is when we're starting, and then right here is where we hit the end of the first quadrant, the end of the second quadrant, the end of the third quadrant, and then the end of the fourth quadrant. And then what happens if you think about your circle is it just repeats. And so if you can kind of figure out those first few values of your graph for sine and for cosine, it will just then continue to repeat. And then you just connect your points in a smooth curve. So this graph right here is cosine. And so again, if we think about our cosine graph the same way, when our theta is 0, our cosine value on our unit circle is 1. When theta is pi over 2, our cosine value is 0. When theta is pi, our cosine is -1. When theta is 3 pi over 2, our cosine is 0. And when theta is 2 pi, our cosine goes back to 1. And again, it just repeats. And so if you notice how we're labeling these graphs with the pi over 2, pi, 3 pi over 2, 2 pi, we're labeling them with kind of the values of the axes after each quadrant. So that way it's easy to just quick plot those points on your graph. Your domain of your sine and cosine is the set of all real numbers, and your range is -1 to 1. So this is your range right here, right, of your basic cosine graph, because again, and sine, if you go back to this slide, if you notice the maximum value was at 1 and the minimum value was at -1. So that's our range, but our domain goes forever. It'll just keep going around and around. So our domain is all real numbers, or we could say -infinity to infinity. Each function has a period of 2 pi. So that's important. So a period means how long would it take for this to start over again and to recycle, right? To go back through its cycle. And for sine and cosine, it's 2 pi, which 2 pi is the distance around your unit circle. Right? So every time it makes a trip around the unit circle, then it starts repeating over and over again. And so then again, that information we just talked about, and we're looking at these two graphs. So for me, when I'm graphing sine and cosine, I just remember that sine starts at the origin and goes up to 1, and cosine starts at 1 and goes down to the origin. So just as a little, you have to just remember where each of them start, or use your unit circle values. All right, to sketch the graphs, we've talked about this already a little bit. You can sketch those key points on your axes. And so here's a chart, right? So when it's 0, we have our sine and our cosine graphs. When we're at pi over 2, and again, remember, this is your unit circle. where we're at 0 and pi over 2 and pi and 3 pi over 2, and then we go back to 2 pi. Okay, and then just that reminder that on your unit circle, when we're looking at that x and y coordinate, your x is your cosine value and your y is your sine value, right? So if we were looking at this point right here, this is the point 1, 0. So this is your theta. So when theta is 0, your cosine is 1 and your sine is 0, which is what we have right here, right? When theta is 0, your cosine is 1 and your sine is 0. And then this talks about your symmetry. So when you look at your graphs, your sine is symmetric about the origin, and your cosine is symmetric with the y-axis. So what that means is your sine graph, and again, I'm going to scroll back up so you can see this. Your sine graph right here, the top one here, is symmetric about the origin, which means if you were to take this and rotate it 180 degrees about the origin, you would end up in the exact same spot, right? So when you can rotate it 180 degrees, that makes it an odd function. So your sine graph is an odd function. Your cosine graph, though, if you notice, it has this reflection symmetry across the y-axis. So when you can reflect across the y-axis, that makes it an even function. Okay, so that's what this slide down here was talking about right here, the odd and even functions. The sine function is odd, the cosine function is even. All right, here's your basic characteristics slide that just gives you all of your information that we've been talking about. The domain, the range, period, the x-intercepts. If you notice for sine, we're talking about right here, it says n pi. So at 0, at 1 pi, at 2 pi, if you kept going, it would be at 3 pi, and then the negative pi, negative 2 pi. Okay, your y-intercept is at 0, 0. It's an odd function and it has origin symmetry. Your cosine has the same domain and range and period. But here, if you notice, your intercepts are at the pi over 2's. So it's at 1 pi over 2, and then it's at all the odd pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, and then you could be negative pi over 2, negative 3 pi over 2. Your y-intercept is up at 1, 0, 1. It's an even function, and it has y-axis symmetry. All right, so what we're going to do is we are going to sketch a graph of 2 sine x by hand, and we're going to sketch it on the interval from negative pi to pi over 4. Okay, so it's our sine function, okay, but this number out front, and we'll get to this in a little bit, a slide for it, is called the amplitude. Right, and the amplitude is really just a vertical stretch. Right, so what this is saying is we have a vertical stretch of 2. And so what that would mean, if our vertical stretch is 2, then our range, instead of being negative 1 to 1, our range would be negative 2 to 2, because we're going to stretch that y value vertically. All right, so I'm going to draw my axis from negative pi to 4 pi. So if I draw my y-axis and my x-axis, so if I have negative pi, and this is negative pi over 2, because remember, I want to have all of those axes values. So then I would have 1 pi over 2 pi, right? And then 2 pi. Oh, I probably should have gone over to the left a little bit more. We'll slide it out. And then 3 pi, and then 4 pi. Oh, it doesn't want to draw the little pi. There it goes. All right. And then we know that our range is negative 2 to 2, so our range will go up to 2 and down to negative 2. All right, so when we're graphing our sine graph, remember your sine graph, you think, well, when x is 0, if you plugged a 0 in for your x, right? So if we said 2 times the sine of 0, we know the sine of 0 is 0, so 2 times 0 would just be 0. So when your x is 0, your y is 0, which means we're starting at the origin. And then normally your sine goes up. And it normally goes up to 1, but because we're stretching it, we have to stretch it all the way up to 2. And then back at pi, we're at 0. And then at 3 pi over 2, we would be down at negative 2. So it just has that pattern. It goes up to 2, to 0, to negative 2, then it goes back to 0, and then it follows that pattern. So back up to 2, to 0, to negative 2, back to 4 pi. And remember, your sine graph, if we haven't shifted it at all, should be crossing at all your whole pi values. So then if we go to the negative direction, since we went up to the positive and the negative, we need to go down to negative 2 and then back to negative pi. And then what we can do is we can just connect, oh, this is going to be rough, connect all of these points for our sine graph. And if we look at the next slide, this gives you kind of a better graph of the one that we just drew. And this shows you the regular sine function is the gray one. The light gray is just your sine when it only went up to 1 and to negative 1. But then that was just stretched by 2. So then that's why we went up to positive 2 and down to negative 2. Okay, so amplitude and period. We've already talked a little bit about amplitude. So your amplitude is your A value, which is convenient that they both start with the same letter. So your A is your amplitude, okay? Your period of your function, well, I guess going back to this part right here talks about it's your vertical stretch or vertical shrink. So if A is greater than 1, it will be a stretch. But if it's between 0 and 1, or if it's like 1/2, it would be a shrink. And that's what this says here. When the absolute value of A is greater than 1, it's stretched. When the absolute value of A is less than 1, it's shrunk. So when we have the y equals A sine x or y equals A cosine x, your A value is your amplitude, but amplitude has to be positive. So make a note right here. Your amplitude is the absolute value of A, which means that your amplitude is always positive. If there's a negative in front of it, then that's just a reflection. That doesn't actually mean your amplitude's negative. So your amplitude always has to be positive. All right, so let's look at these two examples here, and we're going to sketch a graph of each one, and we'll just go, to make it quick, we'll go from 0 to 2 pi, so we'll just do one cycle of our graph, right? And so we're going to start first by drawing our axes. If we go 0 to 2 pi, so if I go out 0, this is pi over 2, pi, 3 pi over 2, 2 pi. Okay. And then right here, this 1/2, this number in front is our amplitude. Right? So normally in just your parent function, it's a 1, which is why it goes up to positive 1 and down to negative 1. So in this case, it's 1/2. So instead of going up to 1, it's only going to go up to 1/2, and it's going to go down to negative 1/2. Right? And when you're drawing your own axes, you can just draw them with that amplitude already in there. Okay, so now let's draw cosine. Remember the last one we graphed was sine, and it started at the origin. And cosine always starts up, because if we plug a 0 in for our x to figure out where we're starting, if we do 1/2 times the cosine of 0, we know from our unit circle that cosine of 0 is 1. So we would get 1/2 times 1, which means when our x is 0, our y coordinate is going to be at 1/2. Right? And then from there, it goes down to 0. Because remember, at the pi over 2's is where the cosine crosses. At pi, it will go down to negative 1/2. it will go back to 0 and back to 1/2, and then it would just follow that pattern. So then when you draw your curve through there, right, it would just keep following that pattern all the way through. Right, if we look at this next one, if you notice, your amplitude in this case is 3, right? So if our amplitude is 3, then that means that when we're drawing our graph, we would go up to 3, and we would go down to -3. And so if we're going out to 2 pi, and then we can split that into fourths, right? Because then that's our pi value, and we have our other quadrants. It's still cosine, so it's still going to start up. Instead of starting at 1, though, it's stretched up to 3. And then it would go back to the axis to -3, back through the axis, and up to +3, and then you just connect your points. Okay. So something like that. So when you have those amplitudes, everything stays the same except for those y values get stretched from -1 to 1, or they get shrunk, either bigger or smaller. So then here's just the solution of the two graphs. If you want to look through them, it just shows you, again, that gray graph was your parent function, and then what happened when we shrunk it, it got kind of shorter, and when we stretched it, it got taller in both directions. So when we have the negative in front, this negative out front here, that reflects your y values. So this reflects your y values, and it will reflect them over the x-axis. So it reflects your y values over your x-axis, right? And so if we look at this graph right here, the -3 cosine x, our amplitude, remember, always has to be positive. So our amplitude is 3, but this negative right here is a reflection over your x-axis. So what happens with your cosine graph, if you notice, I guess I'll go green since we already have red and blue. If you notice, the red is your cosine that normally was stretched up 3, but because we have to reflect it, it actually goes from +3 and it reflects down to -3 down here. And then it follows the pattern. Then it goes back to 0, up to +3, back to 0 to -3. So again, it's just finding that starting point and then going through that pattern of hitting the axis, going to the other end of the amplitude, and then going back to the axis. And so now, though, we're going to add another letter into this. So we've talked about the amplitude and the reflections. So now we have, when your sine and your cosine, it's not just an x, but there's some other constant in front of it, which we'll call b. So what happens is that is your horizontal compression or stretch. So horizontally, we're either compressing it or we're stretching it. And horizontal is your period, right? Because normally we were graphing from 0 to 2 pi, right? And that was the period of one cycle. And so if we're compressing or stretching, what happens is our period changes from 2 pi, right? So your period of your graph changes to be 2 pi divided by whatever that b value is. And that's what this little box says right here, that the period of your graph is 2 pi over b. And so again, if you have y equals the cosine of x, right, technically in front of your x value is a 1, which is your b value. So that's why your period, if you did 2 pi divided by 1, you would just get 2 pi. You know, if we had y equals the sine of 3x, right, our b value would be 3. So the period, the length that it would take to get through one cycle, would be 2 pi divided by 3. It's just that b value, in this case, would shrink it up. It would make it a faster trip to get through the cycle. Okay? And then we have translations. So where we're shifting horizontally. So that letter that they use is C. So far we have A, B, and C. So C is your horizontal shift. Remember, if you have the minus C, the negative, you're going to the right, right? And the positive, you would be moving to the left. Okay? But you have that B value in there. So what you have to remember then is that we call the horizontal shift the phase shift. So your phase shift is your horizontal shift. Right? And your horizontal shift, the way that you determine what it is you take your C value and you divide it by your B value. So C over B tells you how it's shifting horizontally, and then you just have to look at the sign in front. So this is kind of all of the stuff we've talked about in one slide. With your amplitude is the absolute value of A. Your period is 2 pi over B. We'll add in there that your phase shift is C over B. Right? So we have all of that. And so here, when we look at this, the only thing we haven't talked about, and I probably should have included it in this slide, is that you have your vertical shift, which they use a D for, and that comes up in another slide. But on these, this next one right here, when we talk about the horizontal translation, there is a vertical shift that we'll have to talk about. But let's first go through this. So if we look at this, our amplitude is the number in front right here, and it has to be positive. So we'll say our amplitude is 3, right, which means it would stretch it up to positive 3 and down to negative 3. Our period, remember, is 2 pi over B, and the B value is what's right in front of your X. So this is our A. 6 is our B value. So our period is 2 pi over 6, which would be pi over 3. Our phase shift, remember, is C over B. So our C value in this case is pi. So our phase shift is pi over 6, right? And because they tell us it's positive, we know it's actually moving negative. So we would say pi over 6 to the left. And then your vertical shift we haven't talked about yet, but your vertical shift is whatever you're adding or subtracting at the end. So in this case, we have a -1. This is your letter D. And so our vertical shift in this case will be down 1. Right? And it didn't ask us about this negative out front, but remember we have this negative out front, and this negative is going to be a reflection over our x-axis. Right? So we're going to have to reflect over our x-axis. Okay? So now what happens is we have to graph this. Okay? And this can be a little bit tricky. So when you graph this, and if we're graphing it by hand, it doesn't give us what we have to graph it on. So I usually just go 2 cycles if it doesn't tell me. And in order to determine the length of your cycle, you look at your period. So here, if our period is pi over 3, then we'll probably graph it. We'll graph it from negative pi over 3 to positive pi over 3, right? Because that would get us through 2 cycles of our graph. Okay? Our amplitude is 3. So here, for our range, if we didn't shift it up or down at all, our range would be -3 to 3, but we're shifting it down 1. So our range, instead of being -3 to 3, we have to subtract 1. So we would have our range would be -4 to 2, right? Because we subtracted 1. And so now when we graph this, if we have to go up to 2, down to -4, and then here's my trick. So normally when your period was 2 pi, we put a 2 pi out here and then we split it into fourths, right? And we could put a -2 pi out here and we could split it into fourths. And that's when your period was 2 pi. So what I would do is still do four dash marks, but on the fourth one, that's the length of your period. So same thing over on the left, that's the length of your period. And so it's like it's compressing all of those quadrants. So it shifts, it pushes everything in, and it will make it easier to graph because then you'll still be hitting those same dash marks. And what happens then, so we've taken care of the period, we have our vertical shift and our amplitude. And then we need to shift everything to the left, pi over 6. So if all the way over here is -pi over 3, halfway here would be -pi over 6. So we're going to shift, it's like we're shifting this y-axis over to the left, right here. So in a way, this point right here is like our new origin. Okay. And so now when we look at our function, we've shifted everything. So now we just have to put our graph in. And now you have to remember, okay, it's a sine graph. Right? And we still have to shift down 1. So I'm going to actually take away this arrow that we said was the origin because I forgot to shift it down 1. So we're going to shift the x-axis down 1, right? And if we shift the x-axis down 1, now this point right here, that's your new origin, okay? So when we graph our sine graph, that's where we're starting, because remember your sine graph starts at the origin, but it starts at wherever that new origin is after you've shifted everything. So our sine graph will start here. At the first dash mark, normally your sine goes up 1, but because it has an amplitude of 3, it has to go up 1, 2, 3, so it has to go all the way up here to 2. At your next dash mark, it goes back to 0, which got shifted down 1. Your next dash mark will go down to -4. So you have that first pattern, and then you just follow that pattern through. We go back to 0, back up to 2, back to 0, right? And then we can go from, we were up, so now we're down, and then we're back up. And so then you can draw the graph through there, right? And it just keeps going forever. Okay, so I'm taking you back to this slide, which was towards the beginning of the slideshow, but this just gives you all of your, like, kind of that whole equation, where here they have the d in the front, but the d might be at the end, right? So you might also see it as like y equals a cosine bx minus c plus d, right? And so then just to brainstorm real quick, so find a blank piece, but let's just remember that your amplitude is the absolute value of A. Your period is going to be 2 pi over B. Your phase shift, and your phase shift is just your horizontal shift, is your C over B, right? And then your vertical shift is your D value. Okay, so all of those different letters, that's really the key in being able to identify all the different parts of the sine and the cosine graphs.